I think we can start. So let's start with Ben and then go up from there.
Sure. Yeah. So I don't know. I read this and mostly I'm just jealous that they have a lot of work done. Because this is it's a lot of work to come with a testing suite like this. So I'm glad they put that high priority. Um, I'm not sure I have anything like particular to add other than I mean this is all necessary stuff. Lots of ways to find issues. I've always questioned their design decision to have four nodes that do the same thing, with the differentiation being we want them to be different instead of let's have four use cases we're targeting and then have the nodes naturally grow around that. And that's not even related to this. Anyway, yeah, it's good to have a good testing suite. MEV is, I don't want to go into too much of MEV, but um, basically, I think Ethereum made a lot of design decisions early on that basically cursed them to have MEV problems for the rest of time. Um, so yeah, I'm glad the system can handle it at least. It's just expensive and sort of warps incentives a bit. Um, Not sure if I have any particular details to add, so I'll just pass it up, I guess.
Yeah. So I was just going through the different kinds of tests they do. So it seems a little less rigorous than what you would do in automotive, where people's lives are at stake. But yeah, obviously they are a little faster. But still they have a lot of tests going on. So because there is a lot of money involved. So that is what something popped up in my mind. And then, yeah, I was just reading about different kinds of attack vectors. So MEV is something I heard. I don't still understand it completely, but that is something like I would like to read about more. And yeah, so it seems just general software testing to me. I don't know what's special in this, but yeah. With that, I'll pass on to Anant.
Yeah, yeah. I mean, my initial reaction when I was reading through this was, this is incredible for sort of like an open source community to come together to sort of have such comprehensive. I know that you mentioned like it's not as comprehensive as in automotive cases, but in a few software projects that I've been involved in, it is always messy to get the testing in order, and I have a lot of sort of soft spots and sort of love for people that can uh, take this up in some sense. It's like the dirty job that nobody wants to do. Like doing research and foundational stuff is like obviously frontier looking, and uh, to me, testing and getting things to production is sort of where the rubber meets the road. So I kind of, from that perspective, I found all the work they've been doing to be incredibly inspiring, to be honest. And yeah, the granular summary was very useful for me to. I've tried listening to the lecture before the last year when they were doing it. I was trying to follow it live, but I couldn't quite follow it. And even this week, while I was preparing for this, I was trying to listen to the lecture, but the summary was more at point, and I kind of supplemented it with other readings, specifically the sort of the mental model for EVM testing components that the summary provided, in terms of thinking in terms of a pre-state that contains smart contracts, balances, code, and storage, and sort of like an environment that can affect the pre-state, and the environment they sort of formulated as containing like all block related info, like the timestamps, the cache limits, base fees, and sort of other metadata, so to speak. That's the mental map I'm having, and the sort of the post state that results as a result of changes in the environment and the pre-state changes. So that to me was a useful mental map to have in terms of at least thinking as I was reading through other testing documentations. It was helpful to see understand at least what they were doing. Previously, it was all gibberish in my in my understanding, but now I can make more sense of it. So that was really useful for me. The fuzzy EVM test was also, I mean, building on that, I thought the fuzzy EVM test was also quite useful for me in terms of understanding the importance of it for client diversity. Did look into, I guess, Lodestar is it a TypeScript-based consensus client, and I was trying to understand its importance in the bigger scheme of things, and sort of reading through those tests after I built the base fundamental mental map. It was useful to see the sort of different fuzzy tests they have to do for different clients. Funny enough, it seems to me it's like on some level it's like some sort of the changes in environment is like could happen at different time steps, so to speak, and that could result in all kinds of weird things in the network and the consensus client network. For example, they're talking about shadow forks and so on and so forth, and that was interesting for me to again internalize. Uh, there was like a couple of other sort of general things, like housekeeping things, like and the videos that was linked in the lecture page, uh, the links that took us to the DevCon archive. I was poking around with the IPFS server, and there was a YouTube link and an IPFS link, and I tried to open it, but it wasn't working for me, and it kind of felt. As much as this testing team is focused on the core sort of EVM machine, at the broader ecosystem level, there's like some dogfooding that doesn't quite happen, it seems, with other adjacent technologies. Like if I look at all of this efforts they put in terms of purely as an economic chain that Ethereum is, that billions of dollars are now flowing through it and it's sort of guaranteed by the Ethereum blockchain, then the sort of the adjacent possible worlds like a decentralized storage or other types of peer-to-peer networks, it's kind of takes a back seat. But if I look at like the sort of the pop culture view of blockchains with all the sort of other applications that all the different uh, chains and other sort of, especially the VC circle, seems to uh, talk about this in fantastical terms about how this is a new compute architecture for everything, like from decentralized social to all the other stuff, then these basics doesn't seem to reconcile with that, like this missing link to IPFS thing on the DevCon page kind of got me thinking about uh, how detached some parts of the ecosystem is uh, from from some of the fundamental developments. Uh, Again, that's where again I find the testing team's effort as as pretty special in that regard. The keeping things going in some, and I also saw that in my effort to try to keep up with what's happening now, I noticed that they have like ongoing. I try to understand the process of how these things work. It seems like there is separate, yeah, for each EIP. There is like a separate call, and there is separate test written for each EIP, and this coordination for all of them seems uh, 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 quite convoluted. But it's good to see this happening, and I could, again, like I said, I could make sense of it better after hearing this lecture and sort of reading through some of the adjacent documents. Uh, yeah, and I also sort of ran into the ETH Panda Ops team. I guess they were sort of famous for like their work during the merge, and their website also has a bunch of useful information on different tools they're using for testing. And uh, the one thing I'll maybe call out is this, I can't pronounce it, it's Zatu stack or something that contains like the different components that you'll need to sort of bootstrap your testing workflow if you are so inclined. I thought that was a useful document along with everything that the lecture page had. Uh, yeah, and let's see. Yeah, I guess those are my sort of initial main thoughts. I will pass it to Venkat.
Yeah, this is a very interesting topic, yeah, and there's actually been a lot of internal discussion about it recently that I was part of. The comparison to automotive is interesting in terms of like actual physical risk. Another dimension of risk that's interesting to consider is the amount of like value at stake. So Anand kind of gestured at that, and we were talking in the meetings I was part of. We were talking about semiconductors as a good comparison, because in semiconductors too, at each stage of the development process, the cost of discovering and fixing a bug is significantly higher, right? Like if you design it if you detect say inconsistency very early in the architecture stage, it's relatively cheap to fix. Like you have a few meetings, you come to a agreement on how to resolve it, and you move on. When you're at the RTL stage, which is the software code that defines the circuits, errors become somewhat more expensive. It might take like person weeks to fix them. The minute you're like actually at the test silicon level, it gets way higher because now you've got all the manufacturing setup costs. And once you've actually started like issuing orders for like large number of wafers, it gets into like millions and millions, right? So if there's like a hardware, if there's a bug that has gone all the way to hardware, then spinning that part is really expensive. So people try to fix it in firmware first. So this logic of like escalating costs with downstream stages is replicated in the Ethereum risk scenario. I mean, it's there in regular software too, but even like more critical regular software, like say, an operating system, it's kind of easier to issue patches and update even like a very large deployment of like millions of installs or whatever. The problem with things like Silicon and Ethereum is that there's sort of an irreversible and high criticality process that's already going, and mistakes compound, right? So even though Ethereum is software, because of the way blockchains work in irreversible ways, kind of has some of the features of hardware. Um, yeah, and you can put a value on this, right? Like once it's gone all the way to mainnet, um, if the chain fails to finalize, there are now billions of dollars at stake. So that's kind of interesting, and I think it would be. I can't quite wrap my mind around like exactly the differences between the dimensions of risk here, but this feels different than like automotive risk, which is more like you get the software wrong, it'll crash and kill people, that kind of thing. There's more of a network effect of risk here. What else? Oh yeah, the recent Pectra upgrade, the issues that popped up were kind of interesting. So the link Anuraj posted is a good summary of that. But the interesting thing is that even though the Pectra code itself was fine, it had like finality issues and stability issues in the DevNet and testnet stages. And they actually ended up shutting down one of the testnets and starting a new one. So that was, I think, Sepolia was shut down, and Hootie was a new network, a new testnet that they spun up. But the interesting thing was the issues that cropped up had nothing to do with Pectra itself. They were actually bugs in the testnets themselves. So not quite bugs, but like I guess some sort of misconfiguration tendency or something. And that got me thinking that if testing infrastructure needs to be sufficiently complex, like it does in this case, like think about something like shadow forks. It's like just shadowing the mainnet and then trying to like fork early to basically provide an early warning system. That kind of system needs to be basically almost as complex as the thing it's testing and monitoring itself. So there's I don't know how to think of this. It's like an autoimmune vulnerability, right? Like the system that's designed to prevent flaws itself is not an attack surface, but a failure surface of some sort. Um, so I'm thinking there's kind of almost a point in the complexity of systems like this, where at some point you have to ask, is the testing infrastructure actually introducing more failure modes and failures than the thing it's supposed to be testing? So I don't think Ethereum is there yet, but the trajectory suggests that such a point exists, right? Like I saw the people dealing with Spectra and all the headaches that went with it. And if you multiply that by like 3x to 10x, which could happen with complexity, then it could be that testnet level failures actually end up screwing up the deployment itself, something like that. So there's something very interesting going on there. What else is there worth remarking about? This whole notion of like devnets and testnets, I think it's an abstraction level of test rigging that kind of didn't exist in previous generations of software types, right? Like you've always had like unit tests and system tests, which this has. You have like testing of different components like the EVM and other bits and pieces. But this idea of like basically testing the entire world that the thing lives in. So it's kind of like a large scale, you simulate the universe kind of testing. So the closest thing I can think of is simulation testing of robots or other things that have like basically ability to model the physics of the system in its environment and simulate the whole thing as it might run in production. So that kind of ability, so full-blown simulation testing, this scheme of like test nets and shadow nets and things like that, this feels new to me. It's the future of like, I don't know, virtual reality for technologies as opposed to virtual reality for people. So there's something very interesting worth thinking about there. Yeah, lots of interesting things to think about, but most of it like way beyond my technical depth. I think that's all I have. Passing to Nathan.
All right. Hopefully my sound is okay and you can hear me. I got a green circle on my side, so I'm going to assume. So yeah, I had a couple different thoughts going through a lot of this. I mean, I think a lot of it, just to echo some of the things that Ben and Anurag and Anant mentioned. Like a lot of this feels like fairly standard software testing. I know Venkat was just saying that this sort of like duplicating system, like entire universe, feels new. But I will say I have worked with clients in my day job that do this something similar for some of their own systems, where they just sort of like fork a production environment into dev for testing. You do have to be careful with that. If for a lot of cloud systems, because there could be like customer data and there are then disclosure risks and things like that. But I'm not sure which came first. I'm not sure if that was something that was picking up on some of these ideas from Ethereum, or if Ethereum's picking up on some of these ideas that were being developed sort of in a more cloudy context. Certainly, they've taken it a lot further than I've seen. I think the problem that they're dealing with here of sort of you have the same set of inputs, you get the same set of outputs. Actually, it feels like it rhymes a lot with some of the problems of reproducible software built, which is a big and continuing area of research. And you would think would like naively when I first ran into it, I was like, how is this a problem? Um, how is it that how is it that you put source code in and you don't always get the same thing out of the compiler, but it actually turns out to be a significant a really hard problem. There's just a lot of non-deterministic parts even in compiling software, and there's it I don't know how close you how close those parallels are. Venkat's bringing applied diversity in chat, and I think that adds significant complication. It would be like trying to get reproducible builds across even different compilers, which I don't think anybody even tries to do yet. But it does seem like there's some parallels there. Thinking about testing, there was also parts of this that reminded me of chaos engineering at Netflix. So I recently learned that has a longer pedigree than just Netflix. So I don't, if you haven't heard of it, chaos engineering is a thing that Netflix does where they actually have a team that knocks out parts of their production infrastructure. And they have a set of tools like one of their first ones was called Chaos Monkey that just kills their production servers randomly. And the point of that was to force their developers to write fault-tolerant software. Now, there's a lot more writing on Ethereum than Netflix. Like it feels like Netflix goes down, they have a bad day, but they come back. They get some bad press. Like Ethereum mainnet goes down, and that's like pretty existential for the project. So I don't know how you could adopt some of that, but it does. Like some of what they're doing is already in testing is already similar about like having machines that like purposefully pushed bad data into some of these test nets and whatnot. And it feels like as things become like Venkat's talked about like testing becomes its own attack surface. Like eventually you kind of have to go, I think, maybe in that sort of direction where you're essentially doing testing in prod. But that's very hair raising, and it requires you to think about production as being this incredibly robust environment that it's hard to think of like how you could do that in Ethereum without like making some of the problems with speed and finality like even greater. The other thought, there was a throwaway in there about they had some problems with low end clients, and that they're being tested now on like Raspberry Pis. I was heartened to hear that. I feel one of my little hobby horses is I feel that a lot of software sort of development kind of assumes that you have reliable network connections and reasonably fast computers, and that is an assumption that is just not true, even in large swaths of the developed world, let alone the entire world. So if you are trying to build like a world computer, like you really do need to be thinking about like these low end clients and network connectivity issues, and things like that. So yeah, I think those were my big things. One last thought, and I brought up this thing about like that it seems to be there's a lot of care in the testing of the core, but that once you get into the broader ecosystem, particularly some of the VC funded stuff, a lot of that seems to go out the window. And I think that did make me start thinking that I think this is a pattern you see again and again, and maybe it's just something that's sort of inherent with how technology is commoditized and pushed out. Is that you have a core set of people who tend to be very thoughtful about the thing, and then when things actually get implemented and kind of pushed out into the real world, the people doing that are oftentimes a lot less careful, and some of that is because they're working under real constraints with time and money. And I do security testing, and I would like to say you should always prioritize security, but like, and you should always prioritize robustness, but like it is it is true that you only have so much money and you can't just like throw infinite amounts of money about that. There is a trade-off point. But that trade-off point for an individual might be different from the entire ecosystem. And there is sort of a little bit of a tragedy of commons aspect to it. And I do think that the unreliability of some of the ecosystems surrounding whether it's blockchain or AI or even just cloud services, like I think that's where some of that, the sort of the incentivization narratives come from. That starts getting courted and people start looking at the entire ecosystem that way. And it's really about sort of differing incentives from around the periphery as opposed to around the core. And I don't know what a solution is to that, but it was something that just occurred to me during this conversation. So those are my thoughts. And yeah, I don't know, it's your show, so I'll pass it back to you, but I would love to hear Ben's rants if we have time.
Yeah, if Ben has something to say, then yeah, please go ahead.
Sure. It seems like you want me to talk about MEV. I don't have too much time, so I think I have a meeting after this. But at the end of the day, the way I would say it is, so Ethereum decided from the very beginning to be a general purpose computer, and that means they tend to think of their problems all in general purpose ways, which is fine. But MEV is like, say, the halting problem in that there's no general solution. At the end of the day, all MEV is two things: it's either information leakage, or it's a race condition. To explain those, information leakage, if you want to trade and you leak information that you want to trade before you trade, worse, if you commit to the trade, leak it, but you still have time to act before the trade actually goes through, they can exploit you. This is true for almost any trades. It's true for almost anything where if you have a competitive or word is slipping my mind right now, the adversarial environment, and you have to commit to an action that people can respond to, they can almost always exploit you in some way. So if you can do that, you're going to lose some money. Generally, you can limit it. It's not infinite most of the time, unless you screw up. But you're always going to lose something. And the other one is a race condition. If for some reason or another a pot of money exists, and the first person to pick it up gets it, everyone's going to try to pick it up, or everyone's going to have a bot that's sitting there waiting for pots to pick up, and there's going to be a race or a fight to get the pot. And of course, if you know the dollar auction logic, people will spend 99 cents to pick up a dollar. And things can get out of control, and you can actually end up things blowing up and people spending multiple dollars to get a dollar if you have a flaw in the system or something. But anyway, these are sort of like the root of all MEV. And you have to think of MEV as not a general problem, but a particular problem, particular sort of smart contracting system to particular flows. Another way I would explain it is like, if you have an ecosystem, you're going to have disposal niches, like scavenger niches, like vultures that feed on dead things. Because things are going to die. And if you have financial flows, you're almost always going to have sloshing and spilling somewhere, and that spill is valuable. And so MEV is almost like a waste stream. And you have to think of, there's no general solution to waste streams. This is the real world. There's going to be entropy. There's going to be loss somewhere. There's probably going to be things that to the right organism or structure or whatever is valuable, that they can try to harvest. But you generally don't want your waste streams to cause too much of a problem. You want to keep that under control. You want a sewer system. You want a way to like, and it's always a specific thing. Like you have to deal with certain things. You really want to think about it in terms of your particular application. What am I blabbering on about? So like Uniswap. Uniswap has information leakage in the way, and I think about maybe the older versions. I'm not 100% up to date on them, but you have information leakage. You have to create a transaction to buy something. That transaction goes into the mempool. People can see it. People can react with it. People can reorder the block. So like you get sandwiched, and you lose a bit of money. So that's an information leakage. You also can have a race condition. If you cover the information leakage, you often have a race condition. So let's say you are able to like sneakily or invisibly transact on Uniswap, what will happen is now the pots will be out of sync with like the rest of the ecosystem, because you've bought something there. You have liquidity is moved around. You can now have, you've opened up an arbitrage opportunity, and that arbitrage opportunity goes to the first person to get it. You have sort of a high frequency trading thing. Everyone tries to rush to build the arbitrage opportunity. One person wins. My point with MBB is you should be thinking when designing these apps, just like when you're designing like an industrial system about the waste flows. You need to be thinking, all right, where are these sloshes going to happen? Is there some ways we get people so they don't get sandwiched? And there is, various techniques from, preventing the information leakage to, like cow swap does something. It's of course, like all complicated things, gets really detailed really fast. But at the end of the day, you have to think, all right, there's an information leakage here. How do we solve that? How do we handle that? How do we prevent it from getting out of control? And then there's, all right, there's, after every set of trades, there's going to be a race condition. Something that I've never seen anyone do that I think is a really good idea is that race condition can be, in the specific case of Uniswap, that race condition can be auctioned off, which is to say, you could have some sort of auction mechanism where someone can buy the right to, after a set of transactions, be the first person in to make a transaction after that, which they can immediately then arbitrage against like Binance or something. So that, and then so and the collective who are selling that right is obviously the liquidity providers. The problem with these race conditions and arbitrages is they actually call, and I despise this name, impermanent loss, which is just saying, if you're getting arbitrage, that money has to come from somewhere. It comes from the liquidity providers. They're making bad trades effectively because you're arbing them. So really, if I were to redesign Uniswap, I would make it so that there'd be some mechanism so that this race condition could be auctioned off, and the proceeds of that go back to the liquidity providers. And I think that's much better design, but that's not how it came out. It'd be more complicated. It's much easier. Yeah, see, and I was gonna, you guys, Venkat just put a thing there. I actually know of Bill Dyan and people who that my problem with them is that I don't think they're not explicitly wrong. Like, I think that obviously waste streams are going to exist. I don't think there's a magical world without waste streams. I don't think there's a magical world where these things are become impossible. I think they're not approaching it the right way. I think that they keep searching for these general solutions, or sort of like an overarching solution that solves everyone's problems. They keep wanting to put it's like they're selling factory design kits, and they want to have a part of the factory design kit that handles the waste stream, and you never have to think about it. You just code your app, and then the waste all the poop all goes away. Where in reality, the precise details of your factory, of your product, of your waste stream, they need to be thought of by the people who are designing the thing. And trying to sort of ad hoc a solution on top of something that's already been designed without considering the waste stream is going to spread shit everywhere. And that's what happens. So I think that summarizes my position. But no, I definitely agree with Venkat and Bill Dyan that this is probably inevitable in some way. And I agree with that. But I just still they're handling it right.
You had said that Ethereum will be stuck with MEV problems for a long time. Why was that?
Well, like I said, if it's like a waste stream, you're always going to have waste streams. You can't not have a waste stream. Like information leakage, there's no probably general solution to make it so that you never have information leakage, and there certainly isn't a general solution to make sure you never have race conditions, because weird things can always happen, and there can always be a situation where the first person to act gets the reward. But I think that they spend too much time thinking about like let's come up with cool proposer builder separations or get people to pay for MEV or whatever. And there's not enough thought on the application layer of how can we properly, control our MEV, minimize it, and try to solve it, if not completely locally, in a way that everything is stable. So that's just my complaint.
More thoughts? 5 minutes left.
For MEV, there's this article called Ethereum is a Dark Forest by the Flashbots people who write and maintain one of the main MEV packages. So this is kind of interesting. Like the infrastructure required to do MEV, it's kind of like actually quasi-legitimate. It needs to be good and work well for MEV itself to not have like bugs and other problems. But yeah, Ethereum is a dark forest theory, is like the pro MEV kind of view in a sense that it's like a Hobbesian everybody kills everybody else kind of world, and that's the way the world is. It's not like trying to fix MEV would be a little bit like trying to make lions and tigers vegetarian because you think killing and eating other animals is bad, something like that. So it's sort of like worth thinking about. That, like one way to think about it is like think about game design. Like if you thought of conflict in game design as a bug, and you said, all right, you can't have like person versus person shooter games, and we will like remove all those features and make it like I don't know, play nicely together game. You're like missing the point of gaming, right? So something like that, I think, is true of Ethereum or crypto in general. Like at some level, you are designing an adversarial system, including adversarial mechanics of the MEV variety. Similar things happen in TradFi, right? You've got hedge funds that pay a lot of money to be located very close to the trading floor, or people spending a lot of money for like extremely high speed links between trading centers. And like if you get like I don't know, nanoseconds of advantage by being like a few miles closer to the stock exchange, you can exploit that with algorithmic trading. And I think overall that's a good thing. And I agree with Ben that the way to police these things is not at a general level, but like um, looking for patterns of like, I don't know, bad sportsmanship in almost like you have the SEC. It polices I don't know insider trading and like very specific patterns that are considered like I would say unsportsmanlike and declared somewhere between like um, loosely bad by norms or outright illegal and you can go to jail, right? So, but they're very specific. The criminal code around like bad actors in TradFi isn't like broad and general. There isn't a crime called crime, right? So you kind of have to be charged with very specific crimes. Like if you guys read Matt Levine, who writes the finance column, he has this running joke of like everything is a security fraud, and it's kind of like very interesting to follow, where he picks up like very specific cases of like company boards are doing like fraud and shows how they fit a general definition of securities fraud according to the SEC. And it's kind of interesting. There are general universal things going on that fit the idea of like securities fraud. But yeah, in practice, it's a whole bunch of specific patterns that you have to like treat with yeah, uh, precedents and specific mechanisms. You can't like generally solve crime. Or yeah, I don't think of this as crime, but yeah, you get the idea.
1 minute left. More thoughts? Okay, I think this was a good discussion. So see you in 2 weeks.